I'm Amanda Fritz. I'm on the Portland City Council. I'm in charge of the Water Bureau, and chose to come again tonight just to continue to hear the conversation of the work that the committee is going to get started doing. And I really appreciate each of you being willing to donate your time to help us make choices that are going to be in the best interests of the neighborhood. Before we get started, I know that there's been, I want to also to thank those people who came to the Portland Utility Board meeting last week. We just did the trip from Portland to here, and so we know this is quite the trek from there to downtown, so thank you for doing that. I just wanted to address an issue that's been in the news this week that you may have seen, that we're buying a property in between letters D and E on the map there. And the reason that we're buying that property is because that's a possible location for having the pipes go off the filtration plant and get them to Dodge Park Boulevard, where then they go west towards the city. So that's what the reason for that purchase is because otherwise my question was, why can't you just go on to Dodge Park Boulevard to the east there, where it's next to the Water Bureau's property, and apparently the topography is such that you'd have to pump the water uphill, and that is not as sustainable as, and it's also a longer pipe connection than taking it across that property. We don't know until we're going to be getting the design consultant contract done probably next month, and until we get the design consultant on board, the reason that what we are meeting with you right now is we want you to help inform what the design contract, how they design the project. But since that property was for sale with a willing seller, we decided to buy it in case we need it. We don't know whether we will need it, but it could potentially also have a connection that you could get trucks and other traffic go through there so that they wouldn't be going along Carpenter Lane. Again, that's something that we want to hear from you, the Site Advisory Committee, as to what you think the best traffic routes, the ideal traffic routes should be for construction and for afterwards. But that's why we're buying the property. There was some misinformation in Willamette Week about we're buying it for storage or for the staff to use, and that's not the primary reason that we're buying the property. And so it'll probably be going to council to ask their permission to buy it, not this coming Wednesday, but the Wednesday after that. And I'm going to be coming back up at the end, and we'll have 15 minutes questions and answers at the end like we did last time. So I'll be here, I'll be listening to what you have to say, and going to turn it over to David Peters, who's going to then talk about what's happening tonight and what the process is from now on.
Thank you, Commissioner Fritz. We appreciate you being here again also to support this process and to answer questions from the neighbors. I want to reiterate what Commissioner Fritz has said and say thank you for being here with us tonight. We do know this is a big commitment for you to be here, and we appreciate you taking the time to do that, because we are very interested in hearing your feedback and thoughts so that we can make this the best project that we can. Before I get too far into the agenda, there's a few new faces that we have with us this week, and so I'd like to go around the room and introduce those folks and thank them for all the hard work that's gone into preparing for tonight. So from the Water Bureau, we have myself, David Peters. I'm the program director. We have Benita Oswald, who's our public information officer and our primary contact for most of the project information. And then we have Kimberly Gupta, who's our treatment operations manager for the Water Bureau. And she's here to help with some of the program tonight. We have brought Dan Spiker back. He's with Jacobs Engineering. He's our facilitator for the evening. We have Jude Grounds with Corello Engineers, and he'll be doing a presentation for us this evening. And we have Libby and Aubrey from Barney and Worth, and so they've taken care of many of the logistics that have gone into putting this meeting together and getting you notified over the past week. And finally, the person I forgot last time in the back is Sam Boreski. He's working the cameras and doing the video for our program this evening. And don't forget that we do have some food out here. Timber Pub and Grub has provided the food this evening, so be sure to grab some either now and eat it while we're going through the program, or be sure to catch some on your way out. You'll notice that there are a few people that are missing this evening. They had some prior commitments, and we recognize that it is a commitment to be here, and you may not be able to make all the meetings. But if that's the case, we'd appreciate just contact Benita and let her know when you do have something coming up for one of our future meetings, just so we can be sure we have an accurate count for setting up for the meeting. So with that, I'll jump into a brief description. We had quite a few questions last week regarding what is a community, get my agreements mixed up, a good neighbor agreement. So we've developed this site advisory group to advise the Water Bureau on how we can advance this project in a way that's going to be consistent with the neighborhood. And we've talked about the outcome being a good neighbor agreement. And we were asked if the Water Bureau has done any agreement like this. And we went back and we've done processes like this where we've worked with community groups on our projects and got their input, but didn't come to a specific good neighbor agreement. So we looked a little farther in our search and found something that is similar to what we would like to see as part of our process, because each project is unique, and this treatment project will have unique features that our other projects haven't. It'll have unique features that will be different than other water treatment projects that have been done in other communities. But what we found was one that's similar to what we've been thinking about, and there's a copy on each of the tables on the corner here that we can pass around. And it's also been copied on our website. There's a link to it. This is one that was done by the San Diego County Water Authority for a 100 million gallon a day water treatment plant. And this is similar to what we've thought about in terms of what the final product would be for our process. And so you might flip through that and get a sense for what a good neighbor agreement will be. And to give you, I'll just go through maybe a couple examples that are in the plan on the types of questions that would be part of that, part of what we're talking about within our group. Because we're at a point that we don't have a design yet. We're still early in the process. I know you don't like hearing that from me again and again, but we don't have the designer on board. And what we're trying to do is get your input ahead of the design on issues that are important to you, because then what we can do is make sure that our designers and our contractors take that information and incorporate it into the plans for this project. So in this example for the San Diego County Water Authority, they've covered things like lighting, traffic, access to the site, and if I can find the right page here, bear with me. I'll give you some examples of the types of questions they asked. So for lighting, it talks about outdoor lighting should not block ability to observe stars and maintain dark skies. Put motion sensors on exterior lighting. Point exterior lighting downward to ensure light does not shine onto adjacent properties. Those types of things are probably thoughts and questions and concerns that you might have, and that's what we'd like to capture for our project. And what we can do with that information, after we've created this good neighbor agreement and have those types of thoughts from you, we can take that information and give it to our designers, and then we would commit to coming back to you as a group and say, this is how we've addressed that concern in our project. And if you go farther back in this document, They've actually written down how they addressed them on this particular project, where they wrote it into the contract that you'll use certain types of lights or motion sensors, or you meet certain criteria for dark sky rules. And we commit to coming back and talking about how we intend to address the comment and make sure we got it right, and talk about and make sure we've covered your concern in the way we're addressing the contract. So that's the reason we're talking about talking with you early in this process before we've started the design, because we can take that information and get it incorporated into those future designs. So so that's one example. Again, there's a link on our website to a copy of that. There's some copies floating around that you can take a look at. And then there's just a couple more slides, because these programs have been done on, our Good Neighbor agreements have been done in several of our neighboring communities. See if I push the right button. So these are some additional examples. I mentioned the lighting comment in that San Diego County one. This is a Good Neighbor agreement that was done for the Oak Lodge Sanitary District in, I believe that's Milwaukee. So their comment was roadway improvements, entrance and roadway adequate to serve treatment facility needs and is safe for neighborhood vehicle and pedestrian traffic. They took that, created an entrance here that met that criteria for the residents. So it's safe for them to get around their neighborhood, safe for pedestrian traffic, and still meets the needs of the treatment facility. Another one for the Lake Oswego Tigard water treatment plant. Maintain pavement condition on Mapleton Drive and Kenthorpe Way during and after construction. So they took that and made that part of the construction contract, that the contractor had to keep those roads up. And heavy traffic from dump trucks and cement trucks takes its toll on roads. So they committed to make sure that those were kept up during that process. Back to the Oak Lodge Sanitary District, they talked about the architectural design, building style, scale, materials chosen to blend with the surroundings and make a correct or compact plant footprint. All of that can be taken into account, and we'll be talking some more tonight about a case study that shows how that was done on a treatment plant as a specific example. And then back to Lake Oswego Tigard, where landscaping, fencing, and walkways should be designed to fit the residential setting. I realize that comment will be different for this group because we're in a more rural setting and not necessarily residential setting. So we'd like to understand from you how is it different than what was described for the Lake Oswego project. So at this point, the rest of the evening is covering several things. We'll be getting into the process of how you want to get to that final document. And Dan will take us through some exercises that will help us talk through that and gain an understanding of how we can do that. We will then go through some background on water treatment and how we treat the water, what the elements of it are, and what we will be taking into consideration as we put the design together. And we'll talk a little bit about how an agreement like this can impact that design. And then at the end, we have a public comment period. So at this time, I'll let Dan take it away from here.
Great, thanks, Dave. All right, you have in front of you, each of you at your table, a summary of what you provided last week. Recall, Nikki took us through a conversation of these, I call them buckets or categories of need or opportunity. And they were along the lines of traffic and wildlife and environment and chemical use and so on. The first page of that handout is the summary of those comments. And you'll notice that, recall that we had a prioritization or a little voting exercise by you, the SAG members, first, and then, of course, your peers in the audience also provided some impressions. There we go. And these are just simply listed in order. Those that got the most votes are at the top. Ones that received lesser votes are at the bottom. This is not in any way, shape, or to suggest that those at the bottom of the list are less important. It's just simply the focus of energy and airtime that we would give to those topical areas. But all will be covered as part of the process. Notice the last two lines on that. New is listed. Recall that there was a catch-all bucket last time we were together. Some things that you had in your thoughts, your questions, that didn't fit within those other 6 buckets. And we sifted through the material here and thought that there might be 2 other categories that represent your ideas and concerns. One is communications, and the second is property and infrastructure. Okay? And we'll look at a little more detail in the back of the packet here. But that's the thought. This is not designed, to suggest that something's more important. It's just simply a way for us to chunk out the material that you want to hear about over the course of the next few meetings. Okay? I'm not going to read through every line item in this packet. You obviously can take it with you and think through it, see if it makes sense. If you want to make any changes or additions, we certainly are available to make those changes. The only other structural element I want to suggest are 2. One is you'll see that under each of the broad categories, traffic, for example, second page, there are topical areas or subcategories. So for example, under traffic, the first one talks about property access. Second one talks about traffic volume. Again, it's just a grouping of the commentary, comments, questions to allow for us to focus. And that's true for all of these broad categories or buckets. On the back page is another set of comments or questions that were even beyond the particular site evaluation and activities of this group. These were questions about funding, about the site selection to begin with, about regulations and permitting. These, we thought, are important things to talk about, but they are outside of the flow of our meeting structure over the course of the next few months. We will do our best to get to these comments and questions and concerns, and if it means that we talking with you individually about these things or having another session set aside to talk about these specifically, whatever it might be, but we're going to concentrate our effort on the 8 groupings of categories of questions in the first few pages of this document. Okay? But we won't forget these things. Okay? Now, next part of this is, recall last time we were together, we talked about having a series of meetings over the course of the next year. We actually meet next month, and we're going to talk about that later, about doing a site tour, an actual, what is it, the Wilsonville facility, is that right, Libby? And we're going to talk about when you'd like that to happen. So that will likely happen in November. And we're going to give everybody a break during the crazy season, the funny season in December. And we'll all come back and join our illustrious group here in January through November, December of next year. So what I'm talking about is the meetings that will take place next calendar year. The idea is that these topical areas will be the focus of those conversations. So for example, we're going to want to talk quite a bit, provide a lot of airtime, if you will, on traffic. And so we're going to really start with that kind of conversation around traffic, what we know about it, get your reflections upon it, what's important to you in more detail, more along the lines of Dave's comments or examples that he showed up there a few minutes ago. Avoid this, think about that, place it here, do this with roads, okay? Then we'll move on to the next topical area. We'd move on to light and noise and then chemicals, okay? It's not to suggest that we cover traffic in January and then forget it for the rest of the 11 months. That's not the case. We'll continue to learn more through the course of our conceptual design and pre-design work that might bring options to this team, to this committee, and ask you, would you prefer option A or option B or option C? So again, this is more along the lines of the airtime that we're going to give these topical areas, answer your questions to the best of our ability, reflect upon and listen to your needs relative to design, construction, and operation. Okay? Okay. Any other comments or questions about those items? We can certainly answer some if there are any among the SAG members. Does that kind of sort of make sense? Okay, good. Okay, now, moving on to the next topical area. As Dave mentioned, we are going to ask you some additional questions about meeting mechanics, as I refer to them. And you'll notice that there are 6 flip charts around the room. And what we're going to have you do is working in teams, I think teams of 2. I'm going to ask the SAG members to stand up, not right now, but in a couple minutes. And you're going to go to each of these stations across the room here. And the idea is we'll have a person there. So Libby's going to be at that station. Aubrey's going to be here. Kim at this one, Dave, myself, and Bonita. And the idea is to get your reflection upon the meeting mechanic components. So Libby over here is going to be asking the SAG members, we mentioned a site visit at the Wilsonville facility. What's going to work for you? A Saturday site visit? A Tuesday afternoon? Just help us understand what's going to allow you the chance to go to that facility and check it out. Now, if you're like Daniel here and every day is a Saturday, it doesn't really matter, right? But many of you have other commitments that you won't be able to make a particular day. Let's hear from you what you believe is the best way to get you in front of that example facility, okay? Aubrey's going to talk about this meeting time frame. We've talked about this SAG meeting being from 6 to 8 and also on a particular day of the week in the first or second week of the month. Help her understand what's going to work for you. Is it a different time frame? Is it a different day of the week, right? Let's make sure that we're able to get you SAG members at these meetings. Maybe avoid as best as possible your missing cohorts here and just make sure that we're delivering to your needs. Okay, so Aubrey's going to help with that. Up here is meeting needs beyond the timing. For example, we offer dinner. Yay. I would hope that you would write down on there, let's keep having dinner, because it's not only a draw, but it also is helpful from the timing standpoint. But what else? What else do we need to be successful in the meeting setting? Does this setup work for you? Does the kind of engagement work for you? Just how does the format work? Okay. Dave is going to have a little more detail about format itself. What do you need to hear from us? I'm assuming you'll need a little bit more education about certain items. I'm assuming you're going to have some opportunities to engage with your SAG members. Continue to listen to the broader public as part of this. Is that going to work for format? Just really drawing from you, how do these meetings in this format work? Okay. I'll be over here on this one, and I call it reaching conclusions. Recall last time when we met with each other, we used the terminology that you don't all need to come to agreement on something. Meaning, we're calling this a good neighbor agreement, but it doesn't mean every single person in the room needs to be emphatically agreeing to a particular element. But what would you like it to feel like? Would you like it to be a little more consensus-based? Would you like it to be what? So I want to hear your impressions as to how you think this group should interact and engage and reach conclusions of the language that we ultimately put in that document. And finally, Benita's going to be over here, and we have, as of now, I believe 16 people who've committed to this SAG group. And we want to beg the question, are we missing a representative portion of the neighborhood? And what would that be? And help Benita understand that in terms of who else might be interesting to have perspectives, ideas, and thoughts that is part of this process. Okay? After we go through this little cycle, we'll hear from each of these people, report out what they've been told, and then we'll come to some reconciliation of what we heard. Okay? So I'm going to just ask you to split up the 12 of you that are up front in these tables. I'm going to ask you just in tag teams of 2 people. Just pick one of these particular stations. Then after a few minutes, looks like we've exhausted our ideas, we'll just simply cycle clockwise to the next spot, and then we'll get your reaction to that topical area. The idea is to just kind of coalesce all your thoughts in one place and reach some conclusions. Okay? All right. You can turn my mic off. I'm done with that for now. Thank you. let's grab a seat, and we're going to go through these and get a reaction. And we're going to go in exactly the same order, all right? So limber up there, Libby, okay? Get ready, okay? All right, tell us about a plant site visit and what conclusions you came to.
All right, many people said any day or time. There was pushback on Saturdays. Most people don't want to give up a Saturday to see a water treatment plant. Sorry, Kim.
I know. Nobody gets that excited about it except me.
Then, taking all of the information I got here, Monday, November 4th, from 8 to 4 p.m. looks like it works for everybody except one person, and we can arrange a special tour for that person.
Good.
Yes.
Oh, perfect.
There we go. I got it.
Did everybody hear what Kim said?
Libby.
Say
Okay,
that
I'll
real
say it
quickly.
again. So Monday, November 4th, from 8 to 4 p.m. works for the majority of people. One person can't make that time, but we'll make arrangements to get them down to the Wilsonville plant. So.
Okay, good. All right. Aubrey.
So in terms of our reoccurring meeting time, we also had a lot of people who were flexible and open, which we appreciate. Thank you. Makes it easier to schedule. Actually, our Thursday evenings are working well. Evenings in general seem to work well. And we had some votes on times, 6 to 8 for folks, and we have a no on Monday and a no on Friday.
I'll
location
second
works
that no
well.
on Friday. Sorry.
Yes.
I live in Seattle, so just the way it goes.
And with the time in place, we'll be able to confirm a location, try and keep it in the same spot. But we did get some input on that as well tonight.
Good. Kimberly.
Thank you. So we talked kind of about the logistics of the meetings. Dinner, folks felt like if we were going to have an evening meeting, that having dinner was nice. But it's good the way it's been. Keep it simple. Definitely no styrofoam or plastics if we can get away from it, but keeping disposables in general to a minimum if we can would be great. Most folks liked the venue, but maybe the Grange is also an option if we were to outgrow this. Folks seem to like the AV and acoustics in this room, specifically in this room. And then another note was just if the group gets larger, then we need to maybe think outside of kind of where we're at. And then the kid distractions, folks felt just fine with those, so that was about it.
Good. David.
So I had the opportunity to talk with folks about format for the meeting, and what I learned was that folks were mostly good with the format that we've kind of lined out, where we have some introductory conversations, we have some education elements, we have the public comment periods. But what we did talk about, there was interest in more large group conversation, all 16 folks talking together as a group to get their comments out and share thoughts and ideas. And they liked the public comment period. It was good to get feedback from the audience as we go. And then we got into wanting more details sooner than later. There's definitely an interest in getting to the design. But even if we aren't to the design yet, getting to us bringing the concepts to the group, the things that we're thinking about, and what we're thinking about as we begin to head into the design. They said we wouldn't have to be committed to that, but start getting those concepts out there.
Great. Thanks, Dave. All right. And I had this conversation. You can give that to Benita. About reaching conclusions, and I'm going to echo what Dave said. It was clear that right up front, more perspectives, more answers, more detail as much as possible. How can we expect to reach some kind of conclusion on suggestions for your good neighbor agreement if we don't have enough information to react to? Fair comment. In particular, I love one of the comments that came up about was, we don't care what kind of concrete you use, that's your decision. Have fun with it. But it's the perimeter and how we interact or engage with the site itself. Light, noise, traffic, as we heard from the priority of the items on the list. So more detail as quickly as possible. Recognize independent priorities. What I mean by that is you all bring certain interests and priorities. The city of Sandy is different than a person that lives adjacent to the facility. And we just have to understand that those ideas are going to be coming out as part of our conversation. So even though somebody might say, well, light and noise affects me because I'm so close to the proximity of the facility, but others aren't that close, we have to recognize those priorities and be part of understanding each other's needs. Yet we hope for consensus in conclusion. That's going to be much more powerful if a broad members of this group are able to say in a collective voice, yes, that's important for us, rather than just a very small subset of it. So the more we can reach conclusion in a consensus environment, that's great. However, there's a possibility that there's going to be a difference of opinion in some circumstances. And I gave the very simple example is, well, let's put the plant entrance on the north side. I don't even know if that's possible, but I just used that direction. And those on the north side are saying, whoa, 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 I don't want it on the north side, I want it on the south side. And then the other people who live on the south side are saying, I don't want that. Okay? We're going to have to kind of come to some sort of recognition of that difference of opinion. And then how do we reach conclusion together through some sort of, I put it in quotes, voting mechanism to allow for some sense of overarching kind of majority of the group. Hopefully those will be less frequent, that we can come more to conclusions together. Bonita.
All right, my section, we were talking about additional membership for this group. And one of the first things that people talked about was maybe someone that was on Cottrell or Dodge Park or Bluff Road, because one of those roads is going to have some significant traffic impact on it. Another person said, anybody interested? Actually, a few people said that they were anybody that's interested in being part of this group, they should be allowed to be on this group. Another person said a person with an easement on their property would be a good addition to this group, and that kind of connected with the pipeline route, another comment someone had, because we need easements for those folks, and they will definitely be impacted. Another person said off of Dodge Park or Carpenter, we talked to all of the adjacent property owners, but maybe just a little bit further down Carpenter, because those people are going to be affected. Multnomah County Land Use and Transportation. We have had conversations with them, and they felt it was probably going to be a conflict of interest, but their planning section will be reviewing our land use application. Maybe we can talk to them again and say, the site advisory group is really interested in having you be a part of this group, or maybe we might want to have a commissioner be part of this group that's in Multnomah County.
Okay, great. All right, so with that in mind, thank you to all our micro facilitators. You did an excellent job. Thank you. I couldn't have done it without you. What we can do is we'll take these comments, these reflections on meeting mechanics, and make them part of our process, okay? Site visit, meeting time frame, right? The mechanics of the format, and so on and so forth. How we reach conclusions together. And Benita in particular will continue to handle the additional membership. Now that we got your ideas, we have a direction, and there could be some additional interaction with some more participants to see if they can meet the obligations associated with coming to these meetings. Okay, thank you for that. To take your advice, I'm going to ask the broad group of the 12 of you to get a reflection upon one other topic, and that is communications. We, of course, this meeting itself is an open public meeting. Anybody that wants to can come, regardless of whether they're on this SAG or not. So that's certainly an open invitation to anybody. Secondarily, anything that's produced as part of this meeting, either for the meeting itself or following the conversations of the meeting, can be made available. And they will be mostly made available on the website, I believe, Bonita. Okay? Thirdly, the example that David showed, the Good Neighbor Agreement, that obviously is a public document too. That's going to be made available to everybody that wants to see it. Okay? So anything that we produce for the meeting and following the meetings as an outcome will be made available in multiple formats and venues. The question I have for you is, you're all bringing your priorities, your interests, your needs to this meeting. And that's what we want. We want to hear that. We want to get your reflection and your impressions, and we want to be educated on the site conditions and what's going to be influencing you and why it's important, so that we can contribute that to the design process, as Dave is going to help us lead through. But what about beyond that? What about the rest of these members back here? My question for the SAG members is, do you think of yourself and would encourage others to come and talk to you as your neighbors, even outside of these meeting settings, to be the ambassadors or the representatives of other members of the community? Would you be willing to have those connections and communications in order to then be bringing that information? Not to suggest in any way that we want to ignore the people in the audience. We have the opportunity to engage with them. But would you be willing to be asked to support some additional perspectives as part of this? So I just want to open that up, get a reaction. Any thoughts about that? Yes, sir.
Our watershed council, thank you. Our watershed council has bi-monthly meetings, and at our November meeting, the fourth Monday, I think it is, we are inviting the Water Bureau to give a presentation on this issue. So there is a forum for people who want to talk about this with the Sandy River Watershed Council, or people who would come to our meetings anyway or are interested in Gresham in November.
And then from those conversations, you'll be able to bring whatever you learn into these meetings, I presume.
Yes, if somebody comes to talk to us about it there, then I can bring that back.
Great, exactly. Okay, other comments or points about that? Willingness, need. Okay, that's exactly what I'm talking about, to be that representative of a collection of needs, wants, or desires. Any other thoughts about that? Okay, yes. Thank you, Andrew.
Now we have a similar thing with the Johnson Creek Watershed Council. It's they've also got a board and an interjurisdictional committee, and people have thoughts about this project, and there's two of us that can come back with those.
Excellent. Okay. Other comments or questions about communications outside of the routine engagement that Benita is helping us manage? Okay. Great. Thank you for that. I'm going to turn it over to Jude to give us Water Treatment 101.
May I use your...
You have that one. Do you want to be mic'd up?
Maybe. I'll have like my hands full. I could try it.
Can I transfer?
Do you want me to do your?
Nah, I can do it.
Okay.
Oh, really? Okay.
Now, unless you want me to stand beside you the whole time.
That might be a little awkward.
Okay, this is supposed to go over your heart.
Okay.
Because that's where all your real issues come from. Okay. And you might need to just put this in your pocket.
In my pocket? Sure.
There you go.
Thank you
Or
very
on your
much.
belt. There you go.
Can everyone hear me okay? Sounds a little weird to me. Good evening, everyone. My name is Jude Grounds. I work with a company called Coagulation Engineers. Can I move this down just a little bit? Still hear me okay? Okay, a little less reverb in my ears. Jude Grounds, I work with Coagulation Engineers. I have been fortunate enough for the past 20 years to work on the planning, design, and construction of many of the large water infrastructure projects that we've seen here in the region. I'm serving as the, under Stantec on the design team. I'm the design manager. My role as design manager is really responsible for taking all of the technical parts and pieces and making sure they get pulled together into a treatment plant that will produce the water quality that we're looking for. Also address all the safety issues for the operators, address constructability issues and bake those into the design. But one of my favorite parts is actually working with you all to answer your questions, understand your concerns, and bake all of those things into the final product here. And I hope tonight to share some experiences. It's really awesome that you all are involved in this project at this stage. We haven't even begun design work yet, and here you are ready to weigh in and ready to influence this thing. It's a bit of a challenge for you, though, because you don't really have anything to comment on. Everything we're talking about right now is kind of theoretical, or maybe it's this, maybe it's that. So what I'm going to try to do today is answer a number of questions for you. The first one is, why do we treat the water? And what are the components of water treatment? How does that work? And also, in the region, there are precedents for the types of things that groups like you have been able to weigh in. So I'd like to share with you some case studies from a treatment plant that Dave mentioned earlier, Lake Oswego Tigard Water Treatment Plant, and the types of things we were able to do to accommodate the neighbors of that plant. Now, those folks got involved a little bit later, so it's a little more difficult, or was more difficult, to incorporate their opinions and thoughts into the design, but I'll show you kind of the results and what we went through there. So how have site advisory groups helped adapt the design and operations of other facilities in the region? And finally, what can we expect to see on these tours? You'll be touring a couple water treatment plants. I hope to get you excited and a little more informed about what you're going to see as part of those treatment plant tours, and help me understand what you're looking forward to seeing more of as part of those tours, because I'll be one of your tour guides on that. Any questions before we get started? One thing I'd love is if you guys would ask questions throughout this. This is a great opportunity to engage all of us, and all of this is new information, so please don't be shy. It's much more fun if this is more of a dialogue than a monologue. So why do we treat water? Obviously, it's for public health. I'm going to talk today about a lot of different treatment processes, but this is just one example, one of those treatment processes, one of the first water treatment innovations that we had in this community. This graph here shows historical death rates for typhoid fever in the United States. And on the y-axis are the number of deaths per year per 1,000 people in the population. And on the x-axis is, of course, the years. So what you see is that actually in 1908, when we first made a connection between chlorination and the fact that chlorine can disinfect certain things, we see the decline of typhoid over time. And in fact, as this was implemented more consistently, we've driven that almost all the way down to zero. And in the 50s, 40s, and 50s, other treatment technologies like filtration that we'll talk about tonight drove not only typhoid, but many other types of diseases to almost extinction. What are the rules for drinking water? Really, the foundation for the drinking water treatment rules that we have today was the 1974 passage of the Safe Drinking Water Act. That really enabled the EPA to really regulate the standards with which folks like the Oregon Health Authority must enforce on water treatment plants here in the United States. They regulate 90 contaminants right now, but they're constantly on the search for other contaminants, emerging contaminants. We're in a world where we're constantly developing more chemicals to help ensure we don't have to iron our shirts in the morning. And it turns out those chemicals can cause problems for us in the end. So the EPA is constantly looking at, casting a wide net to see what types of contaminants are out there, how they're impacting us, and are they worth regulating. So it's a constant kind of iteration in terms of our water quality rules. So how do we select the right treatment process? It's really about looking at your raw water quality and your finished water quality goals and letting that drive the treatment process. And generally, the goal for water treatment engineers like myself is to look at the family of contaminants like turbidity, which is the colloidal material that makes water cloudy, pathogens, dissolved metals, organics, taste and odor, these kinds of things that are regulated, and create multiple barriers for those. Because many of these treatment technologies I'll talk about tonight aren't whiz-bang. They don't knock everything out 100%. They might get 90% or 99% of what we're looking for. But if we couple them with something else that gets 99%, then we're really tackling and meeting our objectives. Now, I would be remiss if I was just looking at today's water quality regulations when we laid out a water treatment plant design. Instead, we need to be looking into our crystal ball and figuring out, well, what's emerging? What kinds of things do we need to lose sleep over today so that when and if we do have to deal with them in the future, we're not caught, flat-footed. One thing that we worry a lot about are fires. Eagle Creek Fire is a fire that encroached very close to the Bull Run watershed recently. And wildfires in watersheds can have a pretty profound effect on the water quality. For example, anyone remember Salem last year? The nation's largest and longest do not drink notice went for almost a month. I was involved in that project, helping them figure out how to retrofit their plant really quickly to remove those algal toxins so that we could get people drinking that water again. Algal toxins is one of those things that at the time we didn't have a regulation for, yet we had a do not drink notice that we had to try and explain to people. So building treatment plants that can deal with those things helps protect agencies from having to go through those types of challenges. Any questions on that before we dive into the weeds. Okay, this is a process flow diagram for something that in the industry we call conventional water treatment. It consists of many different processes: ozone, coagulation and flocculation, sedimentation, filtration, and disinfection and corrosion control for lead and copper. Now the byproducts of all of this are the solids that we've removed from the water, and we have to eventually get those solids to a place where we can separate them, take the solids and do some beneficial use with them, dispose of them, and then recycle that water back to the head of the plant, because we don't want to waste water. So what I'm going to do now is walk through each one of these treatment processes and give you just a little peek under the hood. And of course, I want to focus on all the exciting treatment stuff associated with these things. And I was talking to Andrew Nishihara, a young engineer on our design team, about this today, and I said, I'm really excited to kind of share what treatment really means for these folks that don't really quite know yet. And he said, Jude, they don't want to know about all this treatment stuff. They want to know, is it smelly? Is it going to have lights? Does it make noise? Like, that's what they want to worry about. So please, please, please don't let me forget to talk about smelly, lights, and noise as we walk through these treatment processes. Okay, ozone. Ozone is a water treatment technology that is very common. In fact, every water treatment plant that we've built here in the last decade all has ozone. And you'll see the reasons why at the end of this when we show you what the benefits are in terms of those things, the boxes that it checks in terms of multiple barriers. But I also want to say that as I walk through these, I want you to get a sense of what these things really look and feel like. So at the end of each one of these modules, I'm going to show a picture of the Joint Water Commission water treatment plant, which is a plant that you all will be touring. And I'll just point out which concrete boxes on that site plan represent that particular treatment technology. So you can kind of see, oh, those are the big boxes with lots of water, or they're relatively small. So you can just kind of get a sense. But Joint Water Commission water treatment plant does not have ozone. So instead, I put this whiz-bang graph together for you to show you kind of what the major components of an ozone system are. Ozone system consists of an oxygen supply, typically liquid oxygen, a generator, an injector, and a contactor. And then to ensure we don't discharge any ozone, we quench the ozone, and any gas that goes off the top we destroy. So I'll kind of walk through these piece by piece. Oxygen supply is typically a liquid oxygen, and these liquid oxygen storage containers are very common. If you've ever driven behind a hospital, you've seen a big tower, maybe some are vertical, some are horizontal. That's a liquid oxygen storage, and right next to it are some vaporizers that take that liquid oxygen and turn it into gaseous oxygen. We then take that gaseous oxygen and we excite it. We pass some electrons through it, and a certain fraction of that liquid oxygen then goes from O2 oxygen to O3, which is highly reactive and can just blast the crap out of a lot of organics and other things that are in the water. That is the ozone generation system. We then mix that gaseous ozone and oxygen stream in with the primary flow through the plant and put it into an ozone contactor, because that ozone needs time to react with the things in the water. So we give it 7 minutes for taste and odor, 15 minutes if we're trying to disinfect cryptosporidium. Different things require different contact time with ozone and different concentrations of ozone in the contactor. But in the end, if there's any ozone residual, we quench it, because we don't want to put that ozone out there. It's highly corrosive. So we typically quench it with calcium thiosulfate. It is a non-corrosive, non-toxic chemical. It just gives the ozone something to react with. And any ozone, because we're adding it as a gas that happens to escape into the headspace of this contactor, gets pulled through what we call a destruct unit. And that destruct unit has catalyst in it. It basically passively allows that ozone to react, so that what comes out the end is water with oxygen in it and oxygen off the top. And what also comes out is the destroyed organics, or the organics that have been pulled apart, including things like algal toxins, or the inactivated bacteria, the bacteria that got lysed and are no longer infectious. Questions on ozone? Are you excited about ozone now? Coagulation, flocculation, sedimentation. This is kind of the heart of most of the solids removal at a conventional water treatment plant. Now, those of you, I know there's a couple fishermen in the back, but I don't know if you've ever taken a glass of water. You know, when streams go a little off color, if you were to take a glass of water and put it on your shelf, that water that's unclear would literally probably stay unclear for a month. And the reason is those particles that are in there, they're not going to settle out because those particles have a charge on the surface. Typically, we consider a negative charge. And what they're doing is acting like little magnets in that water, and they're keeping each other in suspension by kind of repelling one another. So they're stabilized in the water. And what we try to do with coagulation is destabilize that particle. We add a little bit of coagulant, and what it does is masks all of those charges and neutralizes them so that those particles can stick together. And if we can get them to stick together, then we put them through coagulation and flocculation. And coagulation and flocculation is a process where we mix them enough to where they can interact with each other, but not so much that we accidentally and inadvertently break them apart at the end. So what we're trying to do is create a large, what we call a flock, a combination of a lot of those little particles. And we try to get that flock to be large enough so that it can settle out in the end. And the sedimentation basin, they're typically very big because the time that the water needs to spend in that basin is the time it takes for that little flock to settle. And if the rise rate from that basin as the water overflows at the end is faster than the settling velocity of that solid, you're not going to settle anything out. So you have to typically make them pretty large. And we have some tricks up our sleeves to kind of make those a little bit smaller, and you'll see some of those on your tours. So chemicals for this, again, coagulant, we typically use something like alum. Alum is something, you know, many, or at least my parents had in their spice cabinet, aluminum sulfate. There's other coagulants. And sometimes we use polymers to kind of help bridge things together. And polymers are long chain organic molecules that typically have a charge. Some of them are neutral, but some of them have a positive charge or negative charge. And that kind of helps bridge things and helps stick them together. It makes them a little more heavy so that they settle out a little bit faster. I forgot ozone. Is it smelly? No. Does it make noise? No. Are there any lights involved? Not necessarily. For coagulation, flocculation, sedimentation, there are a few of those things. Now, again, this is a Joint Water Commission water treatment plant. This is outside of Hillsboro, Oregon. There's many components here. We just talked about, and again, it doesn't have ozone, but we talked about flocculation, sedimentation basins. Those are these big basins here on the edges. And what you see at the very beginning of them are these little, they're mixers basically that are mixing the water. That's the flocculation portion of this. And those mixers do have motors that sit on top of the concrete, and those motors make a little bit of noise. There are ways to mitigate that noise, but they do make some noise. The other thing at the tail end of these is some what we call launderers, but they're essentially big weirs, and water just kind of pours over those into the launderer. So you'll hear, just like a stream as water kind of cascades over rocks, you'll hear that kind of, it sounds like you're next to a little creek or something. The fall is only 6 inches or 9 inches. It's not incredibly loud, but a little bit of noise there. Lighting. We need to do maintenance on this equipment. And in order to do maintenance at night, when things typically go wrong, if you ask plant operators, there needs to be lights there. Those lights don't need to be on all the time. But as you're going out there to do maintenance, you need to have the ability to get out there and maintain them. These days, we typically make them motion sensors. So as you walk out there, the lights kind of go on, and the lights behind you turn off so that you kind of minimize the light pollution. But at older plants like the Joint Water Commission water treatment plant, it may just be a switch that lights up the whole thing. We'll have to kind of ask questions about that as we go out to the Joint Water plant. Questions on this? Coagulation, flocculation? Yes, sir.
Not on that, but just on that particular facility,
Mm-hmm.
how much water can it produce a day, that size facility?
This aerial photograph was taken when this plant could produce 75 million gallons a day. It's about half the size of the Bull Run water treatment plant. When we go out there, you'll see there's actually been some construction. They've built some more filters. They're trying to make this plant a little more seismically resilient. You can see this plant. I said there's a bunch of different flock sed basins. You see these little short, fat ones. And then later, as an industry, we kind of learned, you know, it works a lot better if you make them kind of long and skinny. So as the plant expanded, they changed the configuration of those basins. You'll see more basins. You'll see more of these plate settlers, we call them, to help push more water through those. And the plant that you'll tour is an 85 million gallon a day water treatment plant. Yes, sir.
I think your chart said that the flocculated, the material that settles out then gets disposed of.
Correct.
So for a plant the size of what we're estimating this would be, what's the
You're gonna ask me how many
weekly
pounds per
volume
day?
and what happens to it?
Great question. There is a module here to talk about solids and how we might deal with them at the Bull Run. This treatment plant has a kind of old school way of dealing with solids that we'll talk about during that module. Do you mind if I defer that and then I'll come back to you? Don't let me forget and I'll answer your questions. Any other questions on this? Yes?
No? 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 Dean? No? Okay? No?
Yeah.
I was wondering about contamination. Is the sediments, is it have to be disposed at
In a
like?
toxic landfill or something?
Yeah, or
Yeah.
that, or is
No.
it just?
It's largely silt from the river with little aluminum sulfate in it. So it's, if you were to look at it, it would look like clay. And typically people, we'll talk about it. I'm going to talk about it now. How about at the Joint Water Commission water treatment plant? You see these are kind of cut off, but these are big lagoons. You see these little areas that they've kind of mapped out here? This is what the Joint Water Commission has done over time with all of their solids. They take the solids and they put them in beds and they let the sun bake those beds. Now, it's Oregon, so we kind of have a little limited sun baking time. Sometimes you need to get in there with some mechanical equipment, stir that stuff up, get the wet stuff on top, and work it a little bit. But you can get pretty dry solids that, again, look and feel kind of like dirt clods, essentially. And that's about 35% dry, we call it. So that's the Joint Water Commission water treatment plant approach. They've got a lot of land. Like I said, it's old school. This is what people would do if you go to any old water treatment plant. They have a berm kind of on the side. And that's what they've been doing with their solids for years, is just pushing them on the side. There's one more question in the back.
So do those dry beds, I don't know if this plant is going to have those, but do these dry beds have a smell when they stir them up?
That's a great question. Your first question was, I don't know if this plant is going to have drying beds. The answer is not if the Portland Water Bureau is able to realize a vision that they have right now. There are new technologies that are much smaller footprint, that are much more efficient, that get you a lot more drier solids. And so lagoons or drying beds are not the strategy that the Water Bureau is currently considering for the plant. Instead, they're considering something we call mechanical dewatering. So using some mechanical energy to squeeze the water out of the solids and then dispose of those solids. And that kind of mechanical work, it sounds like it would be noisier, and it would be if you were standing inside the building where that equipment is, but outside the building, you typically don't hear those things. So, and do the solids smell? It smells earthy, musty. It smells like wet mud. You know, if you were to take a shovel full of dirt out of the bottom of a river, that's pretty much what it smells like. There's nothing unique to water treatment plant solids.
And where does the squeezed out water go?
So squeezed out water can go many different places. At older plants here in Oregon, a lot of that squeezed out water goes back to the river. That is not the plan for the Bull Run water treatment plant. The concept for the Bull Run water treatment plant, very similar to the Green River water treatment plant that we recently designed and constructed for Tacoma Water, which is kind of a sister plant for this. It's up in a pristine area, and the concept of discharging that water back into the river, in this case a Sandy, is not something that we'd want to do. So we would plan on doing something called zero liquid discharge, which means we're going to make it as efficient as we possibly can. We're going to take every drop of water that we pull out of there, and we're going to turn it into potable water, and we're going to take those dry solids and we're going to take them off site. And I'd offer, if anyone from the Water Bureau. The water gets recycled back to the head of the plant, treated, and then put into the distribution system. Sorry. Thank you. You guys jump in here if I'm missing anything. Cool. Yes, sir.
You said it's going to be run back out. The first meeting we went to, we were told that it was going to come out at the end, go back up and be put in at the very front, the very first tank, and it's a complete recycling. Nothing will go back into the river. Now you're saying that it will?
No, that's exactly the opposite of what I'm saying. What I'm saying is we're going to recycle all of that water and put it back to the head of the plant and retreat it and clean it up and make it potable. The solids, which are dirt clods, are going to be hauled off site and to some beneficial use to be determined. I don't think we've figured out exactly where the solids are going to go. Sorry if I confused you there.
What kind of volumes are we looking at?
Boy.
Just to chime in there, Mike's asking what kind of volumes are we talking about?
Volumes of solids?
Yes.
Boy, so it depends, right? If the water is really clear and pristine, which the Bull Run, probably one of the most pristine watersheds in the world, I would say, you're not going to produce a lot of solids. But in a river like the Willamette River, you get some pretty off-spec water when you get that first flush during the wintertime. There's some pretty cloudy water. Now, demands are down in the wintertime because we're not irrigating our lawns, so that offsets it a little bit. But you can create quite a roll-away, what am I trying to say here? Trailers full of solids that people would haul off to the landfill. But again, it's a function of how much water you're treating and how dirty that water really is. So I can't tell you exactly the quantity, but we'll see as part of the tours. You can ask that question. You can kind of see in general how much solids are being produced and how often.
And it would vary seasonally.
Yeah, very seasonally, exactly. As the river gets from cloudy to clear to cloudy to clear, that has a material impact on the solids that are being created. Questions on any other questions on solids? Any other questions on flocculation sedimentation basins? Floc sed basins are primarily where most of the solids are removed. So those solids settle to the bottom and we pipe them off to other facilities where we thicken them. And you'll see those facilities when we tour the Joint Water Commission water treatment plant. Yeah, so the question was how many chemicals, how many trucks per week are coming into the site? And again, it really depends on how dirty the water is, how much chemical we need. I'm too nervous to do math in my head right now, but we can come up with those numbers and we can share with you, for example, Tacoma Water, like I said, a kind of a sister plant, really pristine water. We can get some historical data. The plant's been up and running now a couple of years. We can tell you kind of the solids that they haul off, the chemicals that they bring on. They're going to be pretty analogous treatment plants, so we can get that to you, but I'm nervous about taking a guess at the numbers right now. Other questions? Okay, filtration, the heart of the water treatment plant. How are we doing for time?
Good.
We're good? Okay. Filtration for treatment nerds like me is the most important treatment. It's kind of the last barrier for solids to be captured before we put the water and disinfect it and put it into the distribution system. Lots to say about filtration, but essentially it's a box of sand. And typically we put larger sand, anthracite, like coal, on top, and a little bit of kind of smaller sand at the bottom, like a little polishing filter. And these days, we tend to, over time, we've made them deeper and deeper. So these days, a typical media would be maybe 5 feet of anthracite and a foot of sand at the bottom. And what this filter is doing is if you took a really thin cross-section through the filter and you held it up and looked at it, it would look like a screen, basically. And that's exactly what it's doing. It's screening out all of the solids that are trying to pass through there. Those solids that were too small to settle in the flocculation sedimentation basins. Sometimes, not all the time, but sometimes we use those polymers, those long chain polymers, to glue those solids together to make them a little more sticky so they get removed in the filters. The filters are right here on this plant. You can see there's quite a few of them because as the solids fill up in that filter, we start losing the filtration capacity, and we end up having to take that filter offline and we backwash it. And what I mean by backwash is instead of letting water filter through from the top to the bottom, we backwash from the bottom to the top. We stir up all that media and scour off all of those solids, and they spill over until that water clears up, and then we bring that filter back online again, and the sand settles nicely at the bottom and the anthracite settles nicely on top of it. So are they smelly? Nope. Are there lights? Similar to the Flocculation basin, there's lights on top for maintenance and observation, but typically not on at night. And do they make noise? Well, to backwash, we have to pump the water, but typically those pumps are in buildings and certainly would be in buildings for the Bull Run water treatment plant. Questions on filtration? The coolest part of the process? No one has any questions? Okay. Chlorine disinfection and corrosion control is the last step. Chlorine disinfection in this case is kind of the final barrier for pathogens through the system, and typically chlorine is added just like you would get chlorine bleach. Your bleach in your house is sodium hypochlorite is about 6%. What we do typically at water treatment plants is we buy it a little more concentrated, like 12%. The reason they sell it at 6% is because if you held on to the 12% bleach for too long, it would just naturally decay down to 6%, just like the bleach on the store shelves. So pretty common. And then the chemicals for corrosion control. And again, corrosion control is about modifying the pH, or the acidity of the water, and modifying the ability of that water to resist changes in pH. We call it alkalinity. And for that, we use carbon dioxide and soda ash. Soda ash is very common. They call it, yeah, it's sodium carbonate, essentially. You can make it by putting baking soda in your oven. You can buy it at the grocery store if you want to make your own detergents or whatnot. It's pretty common chemical. And carbon dioxide, is what trees need to breathe. The clear wells, where all of this happens, a big water holding basin, they're typically, because water flows through a plant by gravity, they're typically about at grade. And you'll see at the Joint Water Commission, and the Willamette River Water Treatment Plant, these are basins that are buried underground. You don't see them. Sometimes there's a little pump station on top because they have pumps that are dangling into them to backwash the filters and other things, but it's really just the pump station that you see. Everything else is underground. And finally, solids, everybody's favorite topic. Oh yeah, does the clear well smell? Are there lights? Does it make any noise? The answer is no. The only potential noise is from the pumps. And again, we can attenuate. And you'll see that like at the Willamette River Water Treatment Plant in Wilsonville. You'll see kind of the sound attenuation on the walls there that keep the sound from, in fact, you can stand in there and hear all the sound and walk outside in the park and you don't hear anything. So we do have acoustical engineers that can help us mitigate those sounds. Yes, sir?
Do you have fan motors or fans
Yes,
that make noise outside?
Yeah.
That will always be there?
There are HVAC and air handling units and whatnot. What we've done typically these days, historically we'd put them on top of buildings and they would squeak and make lots of noise. They're also harder to maintain up there. So these days we try to put them inside buildings so that we don't create those kinds of noises.
Well, I read an article on where they would, if they have a series of fans, they run them at different pitches or angles, and then it reduces the resonance of it, and so it reduces, I guess you'd say, the noise volume of the facility. Is there any truth to that, or?
Boy, there are acoustical engineers that do just that, and they put in dampeners to ensure those where the inlets come in, that no noise escapes there. That I'm a water nerd, so I can't really comment on that, but it sounds like a clever idea. Solids, we already talked about the lagoons out here. And finally, these are kind of the multiple barriers. So here are all of the treatment processes we talked about, and here's the boxes that they check. And if you look across the boxes, you'll see that our goal is to create at least 2 of those red dots, which shows that they're effective at those things, at least 2 of those in each one of those. So again, creating a multiple barrier approach for water treatment. Okay, moving on. Yes, sir.
We understand that you're concerned somewhat, I guess, about chemical spills or something, that there'll be a hazmat group on site or something. And then we heard something about chlorine gas. How does the chlorine gas evolve in this process?
Yep. So
And potentially into the atmosphere, that you need a hazmat group.
So please.
So we currently use, as part of our current treatment, we use chlorine gas at Headworks in the Bull Run. But as part of the new filtration facility, we're looking to go to sodium hypochlorite, which is the liquid. So we will know, because we were concerned about, we heard your safety concerns. We knew this was something that folks were worried about that lived in the neighborhood. And this was something that we were worried about. So we decided, even though lots of big plants use chlorine gas safely and effectively, and we've used it safely and effectively for years, it was something that we made a decision about to move to sodium hypochlorite. That's a liquid chemical, so we could contain it off-site, or just on-site, just kind of standard, and Jude can speak to this certainly, kind of standard secondary containment. You just build containment right there inside the chemical building to contain any spills, and since it's liquid, you don't have to worry about it getting into the environment. So you wouldn't need necessarily a hazmat team standing by. Certainly we would call folks in if there was some sort of issue that occurred, but you design your plant, you build your plant thinking about worst thing happening, right? This whole tank of sodium hypochlorite spilling, and how do we contain that? So
now it's just liquid spills that you're concerned about.
correct. Yep.
So the question was, now there's just liquid spills that we're concerned about, and luckily I've got a slide here that shows an example of the type of containment that we put on chemical systems, and just a few slides away. Yeah, exactly, sumps essentially. Okay.
Can you tell us if you're going to get much vibration out of this?
So the question was, are we going to feel any vibrations from this? There are some things that vibrate. Blowers, pumps can vibrate, but very, very little. And you might feel it when you're standing next to them. You're certainly not going to feel it when you're far away. Okay. Yep. Other questions? Okay. I'd like to talk a little bit about, this is the case study I mentioned earlier where I worked directly with the neighborhood in order to try and get their engagement and their input into a water treatment plant design. This is a Lake Oswego Tigard water treatment plant. Went from 16 MGD, million gallons a day, to 40 million gallons a day, all within the same site. It was a pretty interesting project. The original plant was built way back when in a field, and this neighborhood kind of built up around it. When it came time to expand the plant, there were neighbors very close to it. So working with those neighbors was important. Now, I mentioned that these folks got engaged much later. There was an early preliminary site plan that had been put together by engineers, and it was the perfect engineered water treatment plant design. But what unfortunately hadn't been considered are all of the neighbors' inputs that were going to be close to these things. So we worked, there's some dates down here from over the course of a year to modify this water treatment plant layout into something that the neighbors could accommodate. And I'm just going to walk quickly through what some of those issues were. Thank you. We designed it to protect, I'm going to step back here so I can read some of these things, to protect neighborhood safety. Just some examples are separation of the work sector, so where people are actually doing the work in the water treatment plant, from the neighbors. So there was like a barrier that separated the plant from the surrounding areas. Pulling all those processes into the heart of the plant and maximizing the setbacks from the neighbors. Where possible, someone asked about equipment. We tried to put all equipment inside buildings, nothing on roofs and things like that. We tried to make the buildings look residential scale. This is in a residential neighborhood, so buildings were small and felt like residential facilities. All the chemicals were delivered close to the heart of the plant and all together. And the chemical systems use the best containment, double storage and these types of things. And this is a slide that just shows an early model that is an interactive model that we worked with folks in order to move things around and make sure that operators could maintain the parts and pieces and whatnot. What this shows is basically the acids on one side of the basin all contained together, the bases on the other, so we avoid contamination and chemical reaction. And even the chemical delivery area was separated in between acids and bases, and any spills that occurred or drips that occurred in there were contained and could be dealt with chemical sumps. Yes, sir?
How high is that structure?
That structure is about 28 feet tall. That's it. I'm getting old, so my memory may be a little dusty, but I think that's about right. Additional community benefits that were collaborated and baked into this design. Some street improvements for the neighbors. Architectural finishes, again, that made it look residential. Fencing to add security and protect the neighbors. An intertie with the residents, so if and when they had a water outage, they could get water from this plant. And during construction, we bussed in all the construction workers to minimize that traffic because we just didn't have room for folks to park on this site. These are some pretty pictures, and again, this was part of the engagement was input from the residents that said, we want a meditation garden. We want a place where we can have picnics and whatnot. Maybe totally different than what you want, but this is the result of that.
How big a plant?
This is a 40 million gallons a day, so about a quarter the size of the Bull Run water treatment plant.
Just seen?
The one before that was 75 million gallons a day, but when you tour it, it's been expanded to 85 million gallons a day, about half the size. This is a picture of the finished product. You can see the types of lights that we have up there. These are shielded lights, so they only light up certain amounts, and that's to minimize the light pollution, but you end up with quite a few of those lights out there so that the operators can safely navigate the surface. So what can we expect to see at our tours? We heard you're interested in seeing things like pump stations and noise. So we'll get to see that firsthand. Chemical safety features, actual heart of the water treatment facilities, and some of the amenities that were built into these plants. Now, I've heard you guys are tired of seeing the pretty outside of these plants. This is the Willamette River Water Treatment Plant in Wilsonville. So I wanted to give you a little peek over the fence into the water treatment plant. You'll be touring this plant in November. Again, there's a nice water feature to bring the neighbors in. They had interpretive displays that describe each of the processes. This plant is kind of the crown jewel of Wilsonville's infrastructure, so they wanted to show it off, and it has been a great plant. And finally, the tour of the Joint Water Commission water treatment plant, currently thought to be scheduled for February 2020. So, if there's time, if you guys had any comments about what you'd like to see, what you'd like to hear more about as part of these tours, we'll make sure and get that information and make it available for you, in addition to the questions I already answered that I wasn't able to provide numbers for today.
What's the decibel limit during the day in construction?
Oh, of construction? Boy, I just don't know off the top of my head, but it can be prescribed, and typically that prescription comes as part of the permit process. And it varies, of course, between noisy cities construction and rural construction. So. A pleasure meeting all of you. I look forward to working with you. Yes, oh, please.
Do you happen to have a handout for everything that you went over here?
We will be posting this PowerPoint online after this meeting.
Thank you.
There's one more question from.
Get my steps today.
You mentioned a plant in Tacoma, you said, that was comparable in some way in terms of the source of the water.
Correct.
Is there any difference in that plant compared to the ones that are expected to be the ones we'll see on tours?
Slight differences. The Green River Filtration Facility includes all of the process steps that I described today. Joint Water Commission water treatment plant does not include ozone, but includes everything else. The Willamette River Water Treatment Plant includes everything that we talked about today. The ozone is located at a different step in the process. It's downstream of the coagulation, flocculation, and also, or flocculation sedimentation. Also, their flocculation sedimentation basin is not a conventional one that you saw. Instead, it's what we call ballasted flocculation, where we not only build a flock, but we stick a piece of sand in there so it settles super fast. So you can make that quite a bit smaller. So you'll see that at the Willamette tour. Other than those things, it's pretty analogous, except for the capacity, obviously.
Thank you, Jude.
Thank you all.
All right. I don't need that. I just need your thing.
Okay.
One last thing from me, and then we're going to turn it over to Commissioner Fritz to get any comments from the rest of the group here. Benita has thought through, in particular, the additional SAG membership, and the thought is good suggestions from this team. So we're going to, through her, it's going to be an open environment. So those who would like to participate in this team can contact her directly. And of course, there's some minor obligations to meet. One, you got to be available, of course, and attend and that kind of thing. But we're open to anybody that really wants to be part of this. And then we'll bring that suggestions to this group as a whole and get your validation to that. There'll be a few things to provide in terms of information, how to contact them, why you think your particular representation makes sense, in addition to the members that are already here. Just a few things just so we have a better understanding of the opportunity. Anything else to add to that?
Thanks, Dan. Yeah, so if you need my information, it's on everything that's published. So just look at that, or I have business cards too today, and you can just get a hold of me. What we're looking for is just like a few sentences of why you want to be a part of the site advisory group, and we will present that back to this group, and we'll make some decisions, or they will make some decisions about who will be on joining them up front.
All right, Commissioner Fritz, you want a handheld? Is that, okay, there we go.
So just to be clear, the group, you will decide who joins you. That would be completely up to you. Thank you very much, Jude. I learned a lot. Did everybody feel good to get some questions answered? I think that's a really good start. We haven't actually awarded the design contract to Jude's firm, but he just pretty much won my heart right there. So thank you. I really appreciated all the input that we got, and I especially whoever said try to minimize the use of single-use plastics. How about if we all pledge to bring our own fork? Because we can have the paper plates, but there's not all that many good non-single-use plastic utensils. So I've started carrying one around with me in my purse, and so it may seem a little thing, but it's our planet is in serious trouble. So again, thank you for being here, and so now anybody who wants to ask a question, make a comment, give advice. I was going to be disappointed if nobody got.
I know it. Now, as I understand it, you successfully fought the feds for 10 years in holding them off and implementing the treatment for cryptosporidia in the water treatment process. So if a miracle happens and we can get the feds to back off on that requirement, would you still push forward on the filtration plant?
Boy, that's a $64 million question. Well, actually, it's an $850 million question. I think at that point it would be a council decision. I mean, the reason we're going with filtration instead of ultraviolet is because, as was just gone through, there's multiple different benefits to using a filtration plant rather than ultraviolet. If we didn't have to do anything, I think we'd have to have a community conversation about, is that going to be a resilient system that's going to provide safe and abundant water for 1 million people for the next 60 years? And I don't know what the answer to that would be. I am perhaps an atypical politician in that I think we ought to be making decisions together, both amongst the city council, but also with our ratepayers, the people who use our water. You obviously would be part of that conversation as well. So I can't really tell you yes or no, because I think there would need to be some significant discussions.
Are the feds going to provide any funding for this portion?
We might. be able to get a low-interest loan from the feds. And there's actually going to be an announcement about that next week. Not that we've got it, but that we've got a chance of getting it. So, no, this is yet another unfunded mandate from the federal government. They're not going to give us money, but they may give us a very favourable interest rate that would allow us to spread the payment over many more years.
With the gentleman, and I say that with trepidation, in the White House, making his EPA back off on all these restrictions, I'm wondering if they're going to say, well, you don't have to do anything now, so we're not even going to give you a loan. Have you looked into that? Because this guy will do it.
It's becoming difficult to predict by the hour, never mind, into the future, isn't it? So I think I have no idea, and I don't think anybody has any idea what the president's going to do next, including perhaps the president. I know. But in the meantime, we are following what the EPA and the Oregon Health Authority has told us we have to do. But yes, we did fight it for 10 years, and I'm sorry it's having to happen now. Go home to, oh yeah, another one.
So the last time you mentioned, we talked about the escalating costs. Now potentially over, if the 50% actually occurs, to over $1 billion. And you had examples up there of stages in which you could do this. So initially it would be less costly and so forth. But is your ultimate goal, though, to do the full over the $1 billion cost, which would, fully provide an adequate system in your eyes, such that, okay, if you just did part of this system now at a reduced cost, and it took 3 or 4 years to do that section, then you'd wait a couple years, then do 3 or 4 more years, and prolong it so the pain to the neighborhood would just be prolonged if you didn't do it all at once?
I'm glad you mentioned that, because I think the second option is not I would have expected that answer. So just, if you're going to do it, just get it done and be gone and get it going, rather than spreading the pain out for another 20 years or more, or worse yet, doing something, little bit of quiet, and then do it again. Am I seeing head nods there? So we've got, yes, but the question is, we could build a slightly smaller plant and then come back and build some more later, which I think would just, it would cost more as well in the long run. So I think the council and probably the consultants are saying, since we have to do it, let's just do it, be done, and make the best project that we can make. So thank you for bringing that up, because I assumed that if I was living here, that's what I would think, but I'm seeing lots of nods, so thank you. I really appreciate, another one?
Thank you. There's a sentence here that says the phased implementation summary meets most projected demands for the next 20 years. What happens after that?
Yeah, that's why I think, but then we'd have to come back and do some more. So I think that's why the council is leaning towards just get it done, bite the bullet. The Bureau got into trouble for estimating the amount that the plant was going to cost without including the amount that the pipes were going to cost. That was a little disingenuous from the critics, because we hadn't decided where we were going to put the plant. So of course you can't say how much the pipes are going to cost. And we still can't, because we haven't decided how many pipes in and out and the route that they're going to go. So we politicians always want to know, well, how much is this going to cost? We have really only a vague idea of how much this is going to cost until Jude and his team have designed the project, until we then get the accurate pricing for whatever tariffs are on at the time, the materials or whatever. It's going to cost what it's going to cost, and we're going to not do anything fancy in terms of, gold taps in the bathrooms or whatever. But we're also going to make sure that the exterior finishing is pleasant to look at, that there is the landscape, and we're not going to cut costs of the so-called extras. We're going to make sure that we've got a facility and a surroundings that's going to be the best it can be for you. So that's what I and my successor in the Water Bureau leadership is going to be considering. But I know you have our commitment that we're not going to say, well, we're going to save a few $100,000 here by not doing something that's really important to all of you. Because we recognize it's going to be an impact on your neighborhood, and we want to mitigate for that to the extent we can.
Do you know when the Bureau will have a notion of how many pipes in and out and what the direction or the alternatives for locating pipes in and out? When does that happen?
We make the conceptual, are we going for the whole, the full implementation within the next couple of months. But then it won't be till Jude and his company have actually designed it that we'll know much more clearly how much it's going to cost.
Not in terms of cost, but it has to do with affected. I asked the question because it has to do with affected neighbors and physical locations and so on.
Well, let me ask you that question then. When will the design be finished? Dave knows? Sorry.
Over the course of the next year, I think, is when we'll be better understanding the actual alignments of pipelines and the size of the facilities. So over the course of the time that we're working with you in this group, we'll be sharing that information as we go along. So most of the selections will be done kind of in that year time frame, and then the second year design won't be done until 2022. The rest of that time we'll be then implementing that. So we need to figure out the routes and alignments and work out all the details on properties and things like that, and then we can get into the heavy design.
And that's why we're asking you to start meeting now, so that you can give us that input on, it's more important to have the entrance here or there, or the particular design elements that are important to you. We can get that in up front, so that it's not like Lake Oswego, where they have the design done and then they have to completely redo it.
One more question? Time for one more question? Anyone?
Thank you very much to the whole team. Thank you for being willing to come back for another meeting and invest your time, and maybe not knowing whether it would be good use of your time. I appreciate that you did decide to come, and I hope you will continue to engage. And to the committee, thank you for promising to engage and see this through. I appreciate it very much. Thank you.
Last few things, logistically, this team will not meet in this room for the remainder of the calendar year. The next meeting will be at the Wilsonville plant, so you'll be getting materials directly from probably Bonita, right, about when and where we're meeting, that kind of thing, and logistically working those things out. Other than that, appreciate you having a great time here tonight. Hopefully, take food. Bye.